Hi, I can see people coming through, so we'll just wait a few more minutes. Shaun, thanks. I can see some more people coming through, so we'll just give it a couple more seconds and then we'll get underway. Well, welcome to the QME virtual seminar series. My name is Samantha Martin, Marketing Manager of Reed Exhibition's mining portfolio, comprising of Amex, QME and WA Mining, and I will be supporting the speakers this week. This is the second session in the virtual seminar series, and if you've not yet registered for the Regional Approach to Transformation, which is happening on Thursday, you can still register online at qmeexpo.com.au. This afternoon's session will examine the application of technology in the manufacturing and METS sector and is sponsored by Control Systems Technology. There will be a live Q&A at the end of the session, and you'll have the ability to submit some questions via the chat box, and we will endeavour to get to these questions at the end of the presentation. But before we get underway, we have a short video from our sponsor, which I'll play for you now. Thank you, Control Systems Technology. Today's session will be chaired by Dr. Sue Keay, who is the Chief Executive Officer at Queensland AI Hub. She set up the world's first robotic vision research centre and now leads CSIRO's Data 61 Cyber Physical Systems program. Speaking today will be Chau, who is the principal at Alphabeta, a leading economic, strategy and data analytics consultancy firm. He specialises in analysing and understanding the impacts of technology on a corporate and government strategy. You will also hear from Dr. Cori Stewart, who is the Chief Executive Officer at Advanced Robotics for Manufacturing Hub. The Hub is a world-leading technology centre in robotics and design-led manufacturing that accelerates the digital transformation. Our final speaker is Professor Jonathan Roberts from the Advanced Robotics for Manufacturing Hub. Jonathan's main research interests are in the areas of field robotics, design robotics, and medical robotics. I would now like to pass over to Dr. Sue Keay for today's session.
Thanks very much, Samantha, and welcome everyone. Thanks for joining us for this session where we're going to have a look at how you can apply technology in the manufacturing and METS sector. And as part of today's session, we're mixing it up with a few different things. So first, you're going to hear a presentation that is going to broadly talk about how you can use technology to stay ahead of the game. Then you'll hear another presentation around some of the facilities that might be available to help you stay ahead of the game. And then you're going to be in for a particular treat, which will be a virtual tour of the Advanced Robotics for Manufacturing Hub. And finally, we're going to round the session out by having a hypothetical where we explore some of the questions that we think are pertinent to the METS sector and how these might be addressed using technology. So first, I'd like to introduce Chau, who is with Alphabeta and will be talking about the economic impact of automation in the mining sector in Australia. Shaun is currently a director at Alphabeta, where he specialises in technology and digital policy and impacts. He previously worked for Boston Consulting Group and was a strategy advisor to Tony Blair at number 10 Downing Street. Please introduce the topic on economic impact, Shaun.
Great, thanks very much, Sue, and great to be here, even if digitally. If you can just give me a moment to share my screen. And Sam, I think you might need to allow me to allow video. Great, thank you so much. Hi, everybody. Can everybody see that? I'll put it on slideshow. Great. So thanks very much, Sue, and really great to be here. The purpose of this talk is really to outline some of the economic impacts of automation in the mining sector in Australia. This work draws on two pieces of work. One was a large study of automation in the resources sector, primarily mining and oil and gas, that Alphabeta completed in 2019 for METS Ignited and NERA. And secondly, we've done a unpublished piece of work on the impact of automation in the mining sector in the Bowen Basin. And this presentation will draw primarily on the first piece of work, but with a few insights from the second piece of work. If there's sort of one overall takeaway before I get into the details, it would be, automation has many benefits and costs that sort of affect different people, different industries, different companies across the value chain. Because it's still an emerging sector and technology, it's really completely up for grabs. So the extent to which Australia, specific companies, the supply chain actually derives benefits from this technology is really up to the people, some of the people in this room. So really my main takeaway is we can really still shape our destinies around automation and the technologies associated with it. And we should, as a kind of sector and as a state and as a nation, kind of think of ways that we can actually productively use this technology and make the most of it for everybody involved. So in terms of what this presentation will quickly address, there are 3 points that I wanted to cover. Firstly, why are we even talking about automation? Secondly, what's the actual impact of some of these technologies, particularly on the mining sector? And very briefly at the end, what can we do to ensure that we maximize the benefits of these technologies? If we start at the first question, why are we talking about automation? So this is a survey that was completed earlier this year. This is pre-COVID. It'd be interesting to find out what the results are post-COVID. But obviously, the context for this discussion is really about, what's going to happen to jobs as a result of automation. And so the question that was posed in this particular survey was, what are the biggest challenges facing those working in the mining sector? And you can see that job insecurity was, very high, as well as, the potential, technology and impact of automation. So, apart from the question about what's the benefit of and the productivity benefits of automation, obviously one of the key pieces of context for this whole debate and question is, what will happen to jobs as a result of automation? So what we wanted to do was really to do a comprehensive and independent assessment of what would happen to, what would be the economic impacts of automation on the mining sector. And that's including things like jobs, but also GVA, wages, CapEx, and productivity. And the way we wanted to study this was to look at 3 things. One was the primary impact. So if you introduce automation technology, so if you introduce, autonomous trucks to a mine, what happens to, the productivity of the mine itself? But we also thought it was really important to study what happens to the supply chain and the wider economy. Because as many of you will be aware, the actual, size of the mining supply chain in terms of, people is much larger than the overall mining kind of employment as well. And then the wider economy flow-ons, which, in economic speak, we call induced impact. was also important to study. And the reason for this is we wanted to look at the holistic impact of automation and robotics technologies on the sector, not just the impacts on primary firms. And so the way we did this was we did a number of surveys with both primary firms and supply chain firms, so over 30 surveys in the sector, as well as we got data from many of those firms, aggregated and anonymized, so we could actually analyze what the impacts would be. And then we built a large model to understand how those different impacts would flow on through the economy. And we did this across 20 specific automation and robotics technologies. On this slide, what you see is sort of the overall kind of benefits from automation technology. So we categorize the sort of different benefits in terms of operational productivity, capital productivity, access to new resources, and systems impact. And you'll see that out to 2030, there is a very substantial increase in total GVA by about $52 billion per annum. And one of the, I suppose, interesting things about it, just to start off with, was that we found that the largest benefits came from, the systems impact potential of this technology. So, in other words, it's not any individual technology, that has the biggest impact. So it's not the automated drill, or it's not the autonomous truck, or it's not the sensor on a drone that has the biggest benefit. It's where you can remove bottlenecks across whole segments of the value chain, so that there isn't a blockage at the port, or there isn't a blockage at the crusher, and where the sort of technology is working together, as efficiently and effectively as possible to ensure that production is increased. And that's a lot, and that's that fourth systems impact. The other two sort of significant benefits were in capital productivity and access to new resources. Capital productivity is more about the efficiency and effectiveness of capital deployment. So it might mean, for instance, that you have to buy less autonomous trucks because you can use them more effectively now. And access to resources was a difficult one to quantify, because it's hard to know how much new resources could actually be potentially uncovered through automation and robotics technology. So we took a sort of fairly conservative estimate there. Slide 6 kind of breaks this down by technology and over time. So what you see here is a graph of the increase in GVA to 2030. So that's at $52 billion. And the different shadings are the different technologies that we looked at to get to the total potential impact. And what you'll see here is, I'm sure it's very difficult to identify the different technologies, but the primary benefit by technology is really in the sort of advanced decision making that mines will be able to take as a result of the technology. So this means operators are getting better data, which means that so they might be getting data from their equipment, which allows them to, or through the processing stages, so they understand how they can better run the mine, or better run specific equipment, or optimize their production. And that's where the main benefit will actually lie. It's from having access to better data, and then improving processes to reduce inefficiencies and improve effectiveness, where we found the biggest potential benefits. And the biggest potential benefits obviously is where you can get more, literally get more ore out of the ground and to customers. If you can improve the sort of efficiency of that process, if you can improve the quality of the ore body, that's where you're going to get the biggest potential impact to GVA. We then did a couple of, we did 3 deep dives of specific technology. This is just one of them. And this was primarily because it was obviously quite topical at the time. So we looked at autonomous haulage in the mining sector, and to understand what the individual impact of autonomous haulage would be. So obviously there's been a number of companies that have rolled out autonomous haulage, and that's actually obviously now expanding beyond iron ore to gold and coal in Queensland. We also looked at how this might apply to the deployment of smaller vehicles. And overall, we found there was a productivity improvement between sort of 15 to 30%, with a net reduction of about 60% of jobs. And this is direct jobs. So this would be a sort of 80% reduction in drivers with potentially a 20% increase in maintenance and control room staff. How that actually breaks down is on this slide. So what you see here, and this is a little bit complicated, but at the top bar is the overall employment in haulage before automation. So this is based on ABS data from the census largely, which is the number of people, direct workers. So that's in blue. So 30,000 direct people employed in haulage before automation. You'll see that there's 106,000 in the supply chain and 83,000 in the wider economy. And what we looked at, and as I said, we looked at all 3 of those things because we thought that it was important to look at this holistically and from a whole economy perspective. And this is for Australia. So what you'll see is there is a reduction primarily in direct jobs in primary firms, with a small increase as a result of some of the new jobs that may come on stream in primary firms. And it's primarily in the supply chain and the wider economy where we would see the uplift in other potential jobs. So here we modelled about a 20,000 person increase in the supply chain and a 15,000 employee increase in the wider economy. And so when we looked at this in total, although there is a decrease in direct jobs, when we looked at the entire economy, we saw that there was an increase in the supply chain and the wider economy. And so net, you get approximately a 10% increase in the total number of jobs across this specific category of jobs. We also looked at this obviously at the sort of global mining level. So this slide does the same thing for employment, but looking at the overall mining sector. So here you see that there was about 150,000 employed in mining, with a supply chain of about 550,000, supporting a wider economy employment of about 450,000. And we went through the same steps of what would the individual technologies do and in combination do to both primary firms, the supply chain and the wider economy. And here again, you see that although there is a reduction in direct jobs, when we modelled this across the supply chain and wider economy, we did see a small uplift in the total number of jobs in the mining sector. And just to flesh this out a little bit more, because this is a question that's often asked, is where do some of those jobs come from? And this is just a very incomplete list, but just a few examples. So it could come from automation implementation, and obviously as firms roll out automation, there's a lot of services that they require to actually be able to automate, and this could be anything from changing the mine design to actually rolling out ICT at the mine. There's also the mining design and construction. So a lot of these opportunities involve changing the shape of the mine, and that is not a straightforward process. Related to automation in particular, there's and vehicles, there's obviously maintenance, there's specific opportunities in ancillary vehicles, and this is everything from water trucks right up to some of the other types of vehicles they have at mines. And then there's the automation infrastructure, which, as I said, could be anything from the ICT to some of the other equipment that's required to properly automate the mine. Talking a little bit about the study that we've recently completed on the Bowen Basin, which we wanted to talk about because it's obviously relevant to some of the people in Queensland. So we've done a very similar study to the overall study we did called Staying Ahead of the Game for the Bowen Basin. This is just one slide from that particular study. And we looked at a sort of a mid-case scenario of automation in the Bowen Basin over 10 years, with about 15 to 20 mines across the basin introducing technology, automation technology, concentrated in some of the larger mines. It assumes, reasonably strong coal prices and demand, and a range of different automation technologies. And we sort of looked at the, we sort of replicated the study that we'd done at a national scale, and we looked at it specifically for the Bowen Basin. And this graph shows the results of that. So here you'll see the starting number of coal mining jobs in regional Queensland, both direct and indirect. Then we looked at the number of workers that would be displaced due to automation, and you can see there's a larger number in the direct jobs that are displaced. We then looked at the jobs that would potentially be created, particularly in the supply chain, getting us to an overall view that moves from about 54,500 to about 55,000. So on balance, the employment effect of in Bowen Basin is forecast to be neutral or slightly positive. Two final slides that I think sort of expose both the opportunity and the risk of automation. We looked at it as a result of our work. One of the key findings was that the majority of jobs come in the supply chain. So the logic that follows from that is that it's creation of jobs in the supply chain that are incredibly important to the overall, at least, employment effects of automation. And so one of the key findings from our work is that if Australia is really to maximise the benefits from automation, and to have those benefits flow through to across the economy, it's really important that as a sector and as a nation, we focus on how we can create those jobs in the supply chain. And this is a sort of worst case scenario, but what it does show is what the blue line, the dark sort of blue line at the top, shows the number of jobs that are supported by mining in the high domestic supply chain case. And then the grey line shows the total jobs supported by mining in the low domestic supply chain case. So you can see that there's a very significant difference between those two lines, and does represent kind of what's in play for the nation and sector as a whole. So what do we do about this? We think that there are four things that need to be done to maximise the benefits. Three things focused around maximising benefits, and one thing around mitigating some of the costs. So the first thing is around sort of cluster development. I mean, clusters have been used across a number of different industries to really exploit the benefits of additional cooperation and collaboration and specialisation. So we think there's a real opportunity to further increase the development in the sector by forming clusters around these types of technologies. And I know some of the speakers and some of the people on this call are actively pursuing this at the moment. Secondly, there's a big part of around skills. So to maximize those opportunities, especially in the supply chain, there needs to be a concerted effort to make sure that, you know, workers and SMEs really have the opportunity to get involved in this technology and understand it, and then build successful businesses, and also, you know, are employed in the sector as a result of it. And the third thing is about sort of developing the overall ecosystem around this technology. I mean, Australia is in a really fortunate position that it's a world leader in rolling out some of this technology across the sector. And so it's about capitalizing on that sort of leadership position and developing, the funding, the training, the testing facilities, the shared plans, the data coordination that's really required to actually make this a reality. And then the final thing, which is also equally important, both from just a pure impact perspective, but also to make sure that we really do mitigate some of the costs, is that obviously our work shows that there are some jobs that are likely to be displaced as a result of automation. So it's very important that as a sector in companies, that there are the necessary plans in place to make sure that people can, you know, land on their feet. And so that's everything from redeployment opportunities, training opportunities, and additional conditional support and incentives. So thank you very much for your time. I hope that makes sense, and looking forward to questions in the session afterwards.
Thanks very much, Shaun. As Samantha mentioned at the start of today's session, we will be taking questions right at the end after the hypothetical. So next, I'd like to introduce us to the next presentation, which is around inside the Advanced Robotics for Manufacturing Hub, which will also at the end include a virtual tour. So today presenting is Cori, who is the CEO of the Advanced Robotics for Manufacturing Hub, a world-leading technology centre in robotics and design-led manufacturing that accelerates industry's digital transformation. While Jonathan, our co-presenter, is the Hub's technical director and also a professor of robotics at Queensland University of Technology. So welcome, Cori and Jonathan. Looking forward to hearing your presentation.
Great. Thank you, Sue, and it's a great pleasure to be here, and it's terrific to be able to speak in this forum around mining and its future. So the Advanced Robotics for Manufacturing Hub is a not-for-profit independent company that's been formed out of a need to collaborate and bring these technologies closer to industry and do more integrated kind of work across the sort of supply chains that help solve problems. So the Hub, just to take a step back and talk about who's got behind it. We're technically only 5 months old, but getting here took a few years, so we're feeling a little bit older than 5 months. It really grew out of initiative on a project called Design Robotics that John will touch on a little bit later, between QUT and UAP. Now, UAP is a high-end fabrication company, but what they were doing was solving very bespoke, unique challenges on each piece of work that really gave a suite of challenges that could be resolved using robotics and other sort of smart technology. So that inspired a lot of cross-industry engagement, said, oh, we could use those technology. We know through your demonstration how that might be able to be applied. So over a couple of years, we had companies from all sectors engage in the project, come and do lots of site visits. We're physically now co-located with UAP in Brisbane's Northgate, and we really distribute our services, particularly across the state, through even Mackay's state development office there, so Peter Barati and team, but also Cairns, Townsville and Rocky through their manufacturing hub. So that's sort of the formation of how we came about. Investing in us also and collaborating with us with their expertise as CSIRO. So they're also a very important part of the nation's robotics capability, and we engage also with their manufacturing capability, which is mostly down in Melbourne, but it's fantastic if you need to prototype anything in 3D printing or really draw into the capability that sits in that very large institution. We collaborate with our robotics colleagues in Robotics Australia group, who are really pioneering the clustering of robotics and being great, and Sue Keay's really the lead of all of this, the spokes voice of robotics for the nation. So really playing an important role about bringing the robotics industry into its maturity here in Australia. We work also with the Fraunhofer, so it's in Germany. They're excellent at building capability around small to medium enterprises, which is the mainstay of manufacturing in that country, and obviously a leading country in manufacturing. The World Economic Forum get behind us, the Innovative Manufacturing CRC, and our main investor, which is the Queensland government. We also engage with the federal government, mostly through projects initiatives, such as Jonathan will probably touch on it later too, a very large training centre that he's heading up. So that's how we came about and who's sort of behind us. The other thing that the other thing we are, before I talk about our experts, is we're a facility, and you'll see that today as you take a little bit of a tour around our learning factory. We work with companies to co-locate here so they have access to Jonathan and the much wider robotics and design and data science teams, and even the business teams who come out here every day helping companies solve challenges. So that's an important part of us as well. This facility you can sort of see, you see a bit of it just behind us right now. Our experts are really the teams that are going out, really working with companies day to day, assessing might be technical needs, might be business process needs, design solutions across a range of challenges. Like I said, we work across industry, so one day we could be talk about aqua farming, another time we might be talking about mineral mining. What we're finding, and what was so important, and we did learn this on the UAP QUT thing, is that the transferability of what we're dealing with in terms of platform technologies applies across. So that's the group. It grows every day. I'm proud to say our latest recruit at the bottom there, David Hedger, has come across from Pittsburgh and Carnegie Mellon as our latest Megatronics capability. The ecosystem looks a bit like this. In our 5 months, we've been generating a lot of projects and a lot of engagement across industry. We reach deeply into the university sector, and we're formalising a lot of those relationships around, challenges that get funded often from the bottom quarter, which is often government. And the corporate sector in the main there is really the equipment and service companies that partner with us. We have a makerspace, which you'll see today, that allows people to come here and solve problems, but also John and his team to be able to demonstrate technology and even broadcast that through a lot of digital screens, or to showcase people who might be elsewhere, remote or interstate or overseas, and also collaborators are able to do a lot of real-time prototyping demonstrations together as well. So that's an important facility. But the networks across the country, so I did touch on this a little bit. We have a deep connection across the Queensland regions, partly because of our strong investment by the state government through the regional manufacturing hubs. In fact, Jonathan and I and others were in Townsville yesterday, and then we're working with the University of Sunshine Coast, building out their new facilities around what can happen in process manufacturing. There'll be stuff happening obviously out near Toowoomba too around food and food manufacturing. And then our network across the country. The ARM Hub is quite an unusual entity in terms of it being a not-for-profit sort of spin out from the university sector with state government money. So it means that our kind of peer organisations in the country are actually the kind of collectives that sit around Swinburne and the Future Factory and Tonsley in South Australia. So we work across that network to make sure that when we do a project with industry, you're getting exactly the right expertise you need on your projects, and that's being delivered and brokered through the ARM Hub itself. And people know also to come to the ARM Hub to get the expertise they might be looking for in robotics or design in the main. So there's a little bit of a summary of kind of the key capabilities that we work with every day. So automation and robotics, data science, image processing and computer vision. So you can start to see where the data and the smarts are coming into each of the applications that we're asked to kind of solve. We really like industry's challenges. So we often, if it's a routine application, we might refer and work with a commercial provider if a company had questions. Where it's really a new challenge is when we really dig in deep and we seek to solve it. There will be an incredible amount of human-robotic interaction, so often thought of as collaborative robotics, and John will probably touch on this as well, that being able to really, one key way I like to think of that is it's really providing companies, perhaps like many of you out there today, who new tools to do their jobs better. And I think Shaun really touched on some of the important things about what's required. We find with the over 100 companies that are working with us now is that it's really about helping to drive productivity, upskilling the workforce on each and every project, so they are the experts of their job and they do get to get the benefits of new tools and new capability rather than really replacing jobs. And I think the work has shown that if we can do that upskilling quick, the industry will suffer less in terms of not really being able to compete, I suppose, in the industry and having then to restructure entirely. So scheduling and learning and machine control and process design. And in design, I like to think about that's a lot of that could be things like workflow. How do you understand how people are going to use the technology? How do you understand where the blockages are? As Shaun also said, so it's not often an individual technology, it is how they all work together. And perhaps the most important thing is making sure you're not putting a blockage in a process. So we do spend quite a bit of time with companies looking at those opportunities, and sometimes they're the challenges as well. I quite like working with a very diverse design capability team, so it's often the best way to engage key parts of staff and executive right down to the person on the floor about how to improve their workplace and get all of that information right up the front in terms of business planning. So the Arm Hub, you can see, is really the practical getting the work done day to day with companies. So I've talked a bit about what our services are, but just to make sure I clarify that into sort of three main deliverables that you can take away with you today. So that industry engagement, making sure we spend time with you looking at your business model, assessing the site challenges and opportunities, so getting that needs assessment in, being able to do some technology demonstrations, so making sure that the problems you want to solve are actually solvable, and being able to do as much as we can instantly within the learning factory, and business networking. So we do things that are social, but we also do a lot of brokering of connections for companies. So a typical project for us might be that you might engage, say, John, since he's here, as an expert for us for around robotic vision, but you also might engage a robotics integration company, and you might be trying to solve, I guess, a more traditional manufacturing challenge on a process line. So it's usually a collective, who are the best people to come together to solve the challenge, and the Arm Hub really is here to try and find the easiest way through that in terms of contracting, IP, process management, trying to make that very agile and really relative, particularly if you're a small to medium enterprise who just needs to be able to work in a responsive way that fits in with your workflow and meets your commercial needs. So we're really trying to, and we do, meet those time constraints for the smaller companies as well. So commercial solutions, this is where I should talk about the contracting, is we can do things quite quickly. We can run our own contracts, even though we're engaging really into the depths of the research capability and bringing that forward. So we do adoption sprints. So you might have a piece of technology. It may or may not be working the way you want it to work. Some companies, we find that piece of technology might be sitting in the corner because you maybe aren't able to use it in the way, or your staff aren't able to use it in the way that was hoped. We often come in and we help with the adoption of that technology and get that running into a process for you. We can demonstrate or validate a new technology, and we do provide just expertise onto other projects too. So you might find that you have a commercial project running and you just need maybe design workshops or 100 hours of John's time on something, and we can actually facilitate that to happen too. So that's very unique. The other part we do is we help people look for the investment needed to de-risk it. So public and private investment, often through grants. So we assemble the teams, we help write those grants because they're really kind of quite tricky. And we find that, and then we really apply to win. So we try and minimise the amount of time we're in a kind of granting cycle by making sure we, benefit from the knowledge of many years of writing those applications. So they're our main services. I welcome any kind of questions about that at any time. Right, I'm going to hand over to John, who can give you a technical perspective.
Thanks, Cori. Okay, so I'm going to talk a little bit about history. So Cori mentioned this project, Design Robotics, which we have undertaken with our industry partners, UAP, but this has been co-funded by the Innovative Manufacturing CRC, and we have university partners in RMIT. And when I say we, I'm talking here about back when this project started, QUT and the Australian Centre for Robotic Vision and others at QUT. So this project was kind of grew out of a much smaller project over about 6 months, where 2 QUT academics were embedded within the business UAP. It's a relatively large project. We're in the 4th year of 5 years, and the project was all about how to help this company UAP adopt robotics for mass customization manufacturing. So this is more about working on pieces that you may only make one of, or maybe a couple of. So this is very relevant to the mining industry and METS in sort of when you think about maintenance, where you may have to get a piece of machinery back to its original shape or form. So it's those kind of, we're tackling those tasks that you don't do in a kind of traditional mass production way. So what you don't have the luxury of doing is spending a lot of money getting something right, because you're then going to repeat it lots and lots of times. In this case, we don't have that luxury. So how do you use robotics in that new way? Lost my mouse. There we go. What we haven't said is really what UAP do, but what they actually do is they manufacture artwork. So I'm an engineer, so I didn't know that much about artwork when we started this project, and I hadn't actually realised that many artists, of course, don't make the artwork that has their name on the piece of art. They, of course, often conceptualize it. They're there as the artwork is created, but there's often other companies that actually make the pieces of art. UAP have a facility here in Brisbane, here at Northgate, in adjoining sheds, and they have a factory in China, and they also have a foundry and factory in upstate New York. And in fact, that factory in New York makes the Oscars. So I'm sure all of you have seen the Oscars, so that's a UAP product, for example. That's one of their smaller things. They tend to make every day much larger things. So this is an example that inspired the this Design Robotics project, which was a staircase at UTS in Sydney by Gary Partners. And you can see this staircase is kind of, it's like a shiny crumpled piece of paper, right? So you get all sorts of very interesting reflections. It's extremely complicated to design, and in fact, of course, it was designed well, with the aid of a computer, because it's so complicated, very complex geometry, so very modern, I guess, design techniques. But what UAP, of course, always tell anybody that looks at this staircase is that they may have used the latest design techniques, but they used a very ancient manufacturing technique. So, and in this particular case, it's made by panel beating, right? So literally somebody with a hammer knocking the metal into shape. So this is the classic example. Modern design, but very old-fashioned manufacturing. So this project was sort of motivated, well, one of the motivations was this previous project. How would we maybe use robots to actually do this kind of panel beating and come up with a more modern way of doing this? You can see there's some construction photos here of this staircase going together. This is another piece of artwork. So this is a lobby of a commercial building. You can see this artwork on the right-hand side, which is made up of a series of metal panels by an artist called Lindy Lee. So these panels, they start off as of completely blank metal panels. And the first part of this process of manufacture was to linish these panels. So those of you who don't know what linishing is, it's a process of literally a sanding drum where a finisher, in this case a guy called Matteo Fantini, would actually linish this piece of metal. So linishing really just stands for linear finishing. It's a very time-consuming and physically demanding job. Matteo, this is an example. I'm going to show you now an example of one of these kind of technology demonstrations, and actually combined with an adoption sprint that we did. So he came to us and said, I need to linish these 8 panels. It will take me 24 hours to do each one of these on the tools. So that, remember, that's 24 hours per panel on the tools. That is very backbreaking work. You would think you could do that in 3 days because 3 8s are 24, but no, it's too backbreaking to do 8 hours in a day. You could probably do a couple of hours in a day, and then you'd have to do something else. So very time consuming, very physically demanding. So this is a great example. He said, I really don't want to spend all of these hours doing this. It's really not a good idea. Can you get me some technology, develop a new tool, do something, use a robot to solve this problem for me? So we put him together with our mechatronics engineer, Amelia Liu, and they started a project together. Now, the significant thing about this project is that the entire project lasted 3 days. Right. So, and in that 3 days, they combined forces. Of course, Matteo's an expert at what he does. Amelia's an expert in robotics. They combined their knowledge and they co-designed a solution. They used an off-the-shelf robot we had in the lab. You can see there, it's a universal robot, the UR10 as it's known. They designed a bracket to hold a linishing machine. They designed a trolley sort of system, a sled system to put it on. They built it, they welded it, they programmed it, they designed the whole thing, and it only took 3 days. The job then took longer, but the job time went from 24 hours per sheet to 8 hours per sheet. And in those 8 hours, and I'll show you a video of that now. Now, there's no sound on this, so I'll continue to talk over it. In that 8 hours, the robot would work for 6 of those hours, and Matteo would do things like spray lubrication on the panel. He would change the sandpaper and the drum. He would adjust a few things here and there, and then he'd have to spend about 2 hours of those 8 hours actually with the tool in his hand, sort of fixing stuff up. So you'll see in this video at the bottom, there's some gaps, for example. So this is a very simple robotic system. But it cut the job time down by 1/3. But more significantly, Matteo didn't have to spend all of those hours on the tools, doing this backbreaking work. The other good news story in this project was Matteo then went on to slightly change his role within the company. So he still does finishing, but he also programs the robots at UAP. So, he kind of upskilled at the same time as doing this adoption sprint and sort of technology demonstration. So this is just an example of the sort of thing, when you get the right people together, the expert in whatever it is you're trying to partially automate, and the automation and design people together, you can achieve fairly significant things. I'm going to go for a walk in a little while, and I'm going to show you the thing we're doing at the moment, which is a kingfisher. So you will see this if you were in Brisbane and you walked along the river outside QUT, you would see this sculpture. It's about the size of a person. I should have taken this photo with someone standing next to it, but if someone stood there, it'd come up to their head. And it's made out of cast aluminium. Now what I'm going to do now is let me take you for a walk, and we'll go down and we'll actually see this cast piece of aluminium. So this is a little bit of an experiment. We're going to break out from the, let me take the run sheet. We'll break out from the tour. Hopefully you don't get too sick. So while we're walking, I'm going to show you this computer model. So this is one of those bird feet. So you will remember in the previous picture, let's go back. You can see the bird feet there. So here is a computer model of the bird foot. So you might think that, and what we're trying to do here is actually effectively sand this bird foot. Now, you think, yeah, we've got a computer model, so that should be fairly straightforward, but it's not quite as simple as that. Let me first of all explain how it's made. So that bird foot, that CAD model I just showed you, the geometry gets put into a milling robot. That milling robot then mills a sand mold, and you can see it being milled here in this photograph. It's then cast. And then out pops a cast robot foot, which you see there. But I'm just going to, let me see if I, with the magic of an extra camera, let's see if I can actually show you some of this stuff for real. Okay, let's see, here we go. Okay, so here is the actual cast product. Now, the significance of casting and then using robots, you can see here the burnishing tool. I'm not going to turn this on. It would be very unpleasant for you to hear. But anyway, you can see the burnishing tool there, the cast product. The problem with casting, of course, is the metal shrinks. So there's actually a bit of shrinkage in this. So what you see here does not match the computer model. Right, and it's actually worse than that. So the process, because they're not actually making a one-off of these particular objects, they're making maybe 4 or 5. So what they do is that the first one that pops out of the mold, they use that as a template to make future molds. So you actually get double shrinkage. So the first one is shrunk a bit, and then they use that first one in all the subsequent ones to make the mold, and then those ones shrink a bit. So you've got this double shrinkage problem. So that leads to you not knowing precisely where the piece is that you're working on. Let's see if I can go back to that. Okay. So what we use is in this particular case, we use a vision system. You can see the foot here in the clean lab before we've moved it to our dirty space here to actually do the linishing. What this robot here is it's taking a sequence of photographs with a three-dimensional camera. It builds up some 3D geometry. And we then get a nice as seen or as built or as cast model of the piece. And it's from that real 3D model that we can then actually work on the piece. Right? So that's how this works. We then use more, I guess, traditional robotic programming techniques. We have to work out path planning. And then we can go and do the finishing of this foot in an automatic sense. So this is yet another example of client coming and saying, how would we do this in an automatic way? Now what I might do from this point on is we'll go for a little bit of a tour. I'm also going to bring up the Q&A screen so that we can you can potentially ask us some questions. If I can find that screen, where is that? Here we go. I'll turn that off. Okay, let me put that down there. All right, I've got the Q&A. Okay. So this is our shed. There we go. All right. So, we have got a very large facility here. We've got a makerspace here. Again, you can see with a range of collaborative robots. So these robots are, in theory, relatively safe, hence the term collaborative robots. Of course, it depends what you place on them. They could be dangerous if you put the wrong thing on the end of them. Let me see. Here, let's have a look over here. Sorry, hopefully I'm not making you sick. You remember I talked about metal bending and panel beating earlier? Well, we've actually got a robotic system. So with our collaborators at RMIT in Melbourne, we have been developing a system to automatically do panel beating. It's a technique known as incremental sheet forming. So you can see here a series of mounds. This took about 20 minutes to make, and it started off as a flat sheet. So this started off as a completely flat sheet of aluminium, and then we programmed in these shapes, and then the robot did the panel beating. Of course, it doesn't really hit it with a hammer. It actually hits it with a very sharp tool and pushes it and stretches it. So it's all about how you actually move the robot around. Okay, so that is our makerspace. I'm going to take you over and show you some of the companies that are actually out at our facility. So over here you see a company called Verton. If you've got a little bit of time, go and look at the Verton website. Let me show you their name so you can look them up. Now what Verton do is they make a device that hangs underneath a crane hook. And this is the idea of this is to replace taglines when you're lifting loads from a crane. Currently, you would normally put some ropes on those loads so that you can steer the loads and get the orientation correct when you're at the far point and the start point of the lift. So these systems are based on spinning weights inside these tubes. There's a full sort of computer control system inside. There's heading control, and in fact, one of these has just come back from a mine. I can't remember which one. Which mine, Cori?
Roti Hill in WA.
Okay, Roti Hill in WA. So that was been doing some trials out there. So this is an example of a company coming to work with us. So we have an active project with this company via the Innovative Manufacturing CRC. So QUT researchers here have helped with the control system. One of their latest modules, in fact, arrived today. I won't go over in case there's secret stuff in there. Who knows what I'm allowed to show you and what not. But you can see these yellow devices here. This is where they're sort of integrated and tested. They're actually manufactured by a company called Products for Industry, again here in Brisbane. They're then brought here for testing and integration, and we help them with some of the control tech. Then over here we have a company called Australian Droid and Robot. They work in the mining sector, developing all sorts of platforms and navigation technologies for mine mapping and autonomy in mine mapping. So they make ground vehicles, they're doing laser scanning and autonomy generally. They're also interested in drones, and again, they use this facility here for testing and development, and their offices are elsewhere. I'm not sure if our painting friends are in, but we have another company, Robotics here, who do a, let's go for a tour outside. So this company is doing, developing a robot for spray painting the outsides of buildings. Here we go. Oh look, they've got it deployed. Excellent. Here we go. You can see some live research. So this robot here extends to 14 or 15 meters and is used to clean and spray the outside of buildings. It's obviously all compact at the moment, but that will extend up here, and it will probably clean the outside of our shed later on with a bit of luck. Okay, thanks, Cori. All right, I think we're perfectly on time, so I might end it there and get the screen back to Sue.
Thanks very much, Jonathan. It was great to see all of the activity happening over there. I might just wait and I'll set the scene while you and Cori get set up. And Shaun, if you could turn your camera back on, where it's now my opportunity to put the panel under the microscope by setting up a hypothetical to get them to answer questions about what might happen. So first off, I have to set the scene. And the scene is that we have, as you can see on your screens, we have 3 city-based technology professionals who find themselves in the Mackay-Whitsunday region keynoting at a local conference. Now, after the event, they are approached by Janet, who's the owner of a local heavy equipment repair company that services the mining industry. So Janet's curious about how she can apply technology to her business. And she explains that her business is dominantly a service business that operates their own workshop, but also sends out field technicians onto sites. They are also a reseller of common heavy equipment components. The main skills that are employed in the business are heavy industrial trades, such as fitters, boilermakers, diesel mechanics, hydraulic technicians, and also she has a sales force. So given that scenario, I'm going to first ask Shaun, what do you see as the future opportunities in the METS sector for companies like Janet's?
Yeah, great question. Thanks, Sue. Before I answer that, just to say, I think Cori and Jonathan's presentation was the best example of something that you can only do on Zoom that you definitely couldn't do in person. So thanks very much for doing that. That was fascinating and a good example of how technology can be an improvement. Yeah, I think it's a really great hypothetical, Sue, and a great question because it really is at the crux of what companies in the supply chain are actually facing. And it sort of highlights why it's anxiety inducing, but also why it's a great opportunity. So the short answer is that, we think that there's lots of opportunity for Janet's business because maintenance, becomes more important as vehicles are automated and as, predictive maintenance and data becomes more important. But it also highlights, the change that would potentially be required in Janet's business to do that and why it's not straightforward. So just to give you a few examples, there's obviously physical repair, which could still be the mainstay of Janet's business, but there's all sorts of things associated with automated vehicles and automated maintenance, and that could be selling bespoke software or hardware, collecting data, analyzing data, providing some of the data infrastructure to be able to do that, doing a lot of the analytics, so predicting where there could be faults, providing advice to the company about how they should manage their entire sort of vehicle fleet, selling other services that, are related to sort of data generally or sort of maintenance of other types of equipment. There's obviously automated repairs, and that could actually be the robotics part of it. There could be wider pieces on implementing automation and maintenance across, mine sites. And that doesn't include, the possibilities for doing this in other sectors where there's sort of similar types of equipment or even potentially exporting it. So really, in some ways, the sky's the potential. And because this is a business that nobody is doing that well, I mean, there's really tremendous opportunity for Janet to expand her business. But obviously, some of the things that I've just talked about are sort of significantly different from the current capabilities in the supply chain. And it's why it's absolutely important that the sector and the nation really invests in reducing that gap in capabilities in the supply chain.
Thanks very much, Shaun. I'm going to ask Jonathan a question now, and that is, what sort of research are you doing that would influence a company like Janet's?
So we're trying to, well, I mean, fundamentally we're doing robotics research, but it's not necessarily engineering robotics research. So we've observed over many years now that adoption of robotics is a problem, and it's not necessarily because the robot doesn't quite do the job right. It's more complicated than that. So a lot of the research we're doing is, as we are doing some of the engineering research, but we're also doing design research and skills research, and in fact, now's a good plug. It's the topic of a new ARC training centre that we were just awarded a few months ago by the federal government, which we've got a new centre starting in collaborative robotics for advanced manufacturing, recognising the complexity that it's not just about the tech itself and not just about the engineering, but it's all those other things as well. So we're trying to yeah, we're trying to get over this adoption problem, which is, and as Cori I think mentioned earlier, we've seen many robots lying in the corners of businesses with tarps over, sometimes with no tarps over, just full of dust. And you know, it's the adoption that's kind of failed, even though the robot does what it says on the box. That's not enough. So we're at the moment, of course, we're trying to focus on the industries that have come to us to be part of that training centre. There's a lot in the maintenance and welding kind of sector generally. The country seems to be very stressed with a lack of welding capability. And we think that there's a lot of research there, both in the robotics end and in the human-robot interaction side, recognising that a lot of these jobs are quite complicated, and they won't be removing the people. They will be giving the people robotic tools, just like I showed with Matteo the linisher. Instead of him having a tool which is now in his hand, his tool is the whole robot plus the thing that was in his hand at the end of the robot. So we're doing all the research to make the robots the tools for the workers.
Thanks, Jonathan. And Cori, how could the ARM Hub help a company like Janet's?
Well, I think Janet's like a very good example of the kind of companies that do come to the ARM Hub. So they might have a specific challenge that might spur them here, and they say, you know, I really want to improve my maintenance capability on the objects. As like she has a workshop, she's got some immediate needs perhaps to automate or clean up and get rid of the dirty or the unsafe work in her team. What are the sort of modern tools that I can use and employ? And so John just spoke about that. That's one aspect only. But then what Shaun's terrifically outlined, it's probably one of many aspects that she can be considering and will need some assistance to work through, both from a business modelling point of view, an investment point of view, and a partnership point of view around how do we take the smart capability, not only of the data that might and capability of the robotics, but it might be other systems. And the data collection being, I think, the key component there. So we obviously have machines now on mine sites that are automated, that are collecting real-time maintenance data, are able to be scheduled, what's her role, or the potential for Janet's business to take over new services there. And so the ARM Hub would help map that and try and provide really the collaboration team necessary to think about that as the stages of rolling out some of that capability for Janet and her business. But also probably the best part is that we will try and de-risk that investigation and opportunity development through research funds or industry development funds, or indeed just collaborations. Because it might be that Janet, buys another business, merges with another business, or brings in new capability, and probably not, it could be new graduates, but it might be very senior capability that already have a small business in real-time data maintenance on mines, and it's a convergence opportunity there. But the ARM Hub does day-to-day look for those collaboration opportunities, and does day-to-day look for the funding opportunity that's ultimately going to help Janet take that next step, and hopefully the step after. Yeah.
Great, thanks, Cori. And for the benefit of the audience, the ARM Hub is conveniently located right next to a railway, so making it very easy to get to.
Right, the trains used to come through the shed apparently years ago to load nails onto.
Well, fortunately, that's not the case now, but every now and then you can hear a train in the background if people are wondering what that is.
Oh, okay.
All right, so close your eyes and picture the next scene in the hypothetical. It's actually 12 months down the track. The panel that we have with us at the moment is reconvening in Mackay, and Janet is in the audience. She has invested in 2 robots, one that can do blasting and the other that can do painting, so that her employees can focus on other tasks. The robots are about to arrive next week, but her employees are threatening a strike. They don't believe the robots are there to help. They think it's a plot to get rid of their jobs. Cori, I'm going to throw to you first.
Yes.
What would you recommend for companies interested in deploying robots?
Yeah, so it seems like that is that is a natural fear for every organisation. It almost doesn't matter if you're already a technology adopting organisation or one that's just about to embark on possibly a technology transfer or adoption process, but highly recommend that the workforce become the owners of whatever the next process is. Ultimately, it's the people in your business that are expert at doing their jobs. They know what needs to be done, what success looks like, what opportunities they will be able to find for themselves in the building of their own skill base and their own careers in building a new skill base. But until that experience is upon them, I think it is somewhat frightening. So I recommend engaging your workforce quite early, making sure that they are leading the process and helping shape the future of what your organisation can do. And actually, they might have some of the best ideas. We have found with most of the companies we're working with, it's not, I'll say it because you're here, it's not because Jonathan walks in and says, hey, this is what a robot can do. It's because they come in and say, this is actually either a really hard task or a really complicated task. How might you be able to help me in doing my job? And at that point, it becomes more of a collaboration process. And we haven't found on any of the projects we work with yet that it really has shrunk the workforce, although we acknowledge that might in some cases in the future be the case in the short term, but it's always grown the workforce. So they're more, more competitive, the productivity is higher, the opportunity that business is able to secure is greater. So typically on the projects that we've done to date, with an example of about 3 companies, it's about every piece of robotic machinery they implement, they're employing about 6 new staff. So it is actually a net gain in the projects that we've been involved in to date. So for Janet though, she's in the conference, she's in the seat, and her workers are telling her, I'm not going to play. This is not for me. I'm really worried about my job. So I think she perhaps better quite readily engage her staff. I would recommend we do a design-led work process around workflow and opportunity with new companies quite often. So it might be, if it's a small company, perhaps like Janet's with under, I'll assume Janet has maybe 12 or so staff. I can't remember if we had a number there. It might be 2 days worth of workshops where they think about all the technologies, they think about the process that they do, and they identify for themselves how they think it might work. And then it's the adoption against those opportunities that the workforce see, perhaps rather than just being an entirely executive-led endeavour. But I think the key thing is to acknowledge that it's natural and normal, but doing a process that's a workforce development process, an upskilling process, and it could ultimately involve training and all sorts of elements, might make the workforce feel more secure in designing the company's future. Yeah.
Thanks, Cori. There are some great practical examples there of some things Janet could do. But now I'm going to challenge Shaun on that, because I guess, from your presentation, there are some jobs that are going to be impacted. So, what's your observation around the economic and job impacts of robot deployment, such as what Janet is trying to do in her business?
Yeah, fair challenge. And just to reiterate the point that Cori just made, I mean, when we were engaging with companies, I mean, this was a repeated thing that, the economic outcomes were one thing, but actually the sort of long-term successful implementation of this technology really depended on the sort of sensitive process that companies were undertaking. So, and it sounds like Janet may not have been as sensitive as she needed to be in this case. I think this is a really good example. I mean, one thing just to say is that when we were looking at this, robotics probably was not as advanced as some of the other technologies, so they were often being deployed in sort of hazardous roles, and so people wouldn't necessarily be displaced. But assuming that sort of robots do actually displace jobs, the reason why the economic benefits do multiply in the supply chain in particular, and this would potentially be a good example of it, is the robots would be sort of more efficient at doing this type of work and potentially also more effective, which means that they could do this effectively at a lower cost than people. And that cost could be measured in a number of different ways. And then the other workers could potentially do other things where they had a comparative advantage. And the overall effect of that productivity advantage should allow Janet to expand her business. And so the overall advantage would be that the business can expand, they employ more people overall, that creates more GVA, and you should see overall holistically a positive economic benefit, and that's what we would forecast would happen in this situation.
Thanks, Shaun. And Jonathan, do you think you could quickly speculate on who's going to look after these robots?
Yeah, that's a very good question. I think this will be probably some of the people that do the job in the traditional way will end up looking after them to some degree. And that is part of the change. So even though jobs may not decrease, or in fact will increase, the nature of the jobs will change. So we have to acknowledge that there'll be change coming, and some people don't like that. So that has to be properly managed. So I think some of these original employees doing the jobs now will maintain them to a certain level, and then there needs to be a whole new generation of robot technicians. I think it's probably a good term for them, that are going to have to service these robots, and it'll be very much like it already is very much like cars. There'll be regular preventative maintenance and services, which probably won't be done by the employees, and then there'll be other things that will be done by the employees. But it's great. It would be great to have in-house capability, which would not be a full-time job. It will be the people that use them day to day, basically.
Thanks, Jonathan. Now, just to round up before we go to our Q&A, just again, close your eyes. Picture that it's 2022 now. You, our panel, you're back in Mackay once again. Janet has joined the meeting via telepresence robot as she's onboarding some new employees on site to help extract value out of all the data that is being created from the new robots that she has on her team. Her business now has a much better idea of what repairs are required, where and when for all of the heavy equipment they service, and they're looking at ways they can sell this information back to their customers and also back to the OEMs as an extra revenue stream for the business. So Jonathan, how much data would such robots collect in a year, and how useful could it be? And I guess, are there other technologies that Janet can add to these robots to increase the value of the data even more?
Oh yeah, that's sort of how long is a piece of string kind of thing, So sensor data on robots is not that significant and very easy to store, and it's no real issue. The really useful data so I should take a step back. One of the things you don't necessarily know what data you need, because there's new techniques are being developed to analyze data. You may just be measuring the wrong thing. So ideally, you throw as many sensors on as possible and collect as much data as possible. One of the very cheap sensors, but one of the most useful sensors, is a camera. I mean, I've got a bit of a bias here because I love robotic vision, but if you're collecting video data, you can get a whole lot of other data from that later on. So it's just worth collecting as much as you possibly can get away with. Now, data storage, of course, is becoming easier and cheaper, but it's really how much you're prepared to store, because you could definitely fill that up, and then there's issues about how long you keep it and all those sorts of things. The one beauty of vision systems and just collecting video data is that you may not need to collect, you can sort of simplify your data collection. You may not need some of the other sensors, because you can, from that video data, you might be able to get location data, for example. You can post-process it and figure out exactly where things moved, and then you may not need other data, other sensors to collect that. So, vision data is, I think, the way to go.
Thanks, Jonathan. Cori, how do you separate out the benefits of robotics versus the benefits of data? Is it possible to disentangle the two?
In some cases, there will be the potential to disentangle them, but let's look at where they're entangled first, I suppose, is where, some robotics in, say, that the maintenance side, say Janet has deployed that painting robot, for example, and she may be getting a certain amount of data just from that robot about the manufacturing process. So I've got a bug here. And that might actually improve her robotics painting process. And that's quite entangled then, because it's the benefits to the robotics process itself. Where it's perhaps disentangled, and I think you indicated that, is where some data maybe across her business is actually really useful for the OEM or her clients in knowing about when to send something for repair, why to send something for repair, or it might be that there could be a logistical bottleneck, and that would become evident in the data. There could be a piece of machinery in the mix that's always causing a particular problem, because you might have that right kind of sensors on that machine that's going to tell you it's rattling so much and that's what's causing the breakdown. It might tell you that some particular employee is really good at using equipment and others don't use it so well and perhaps need some more training. So you can potentially gather quite a lot of insight from your data that might benefit others and the business across the business. I guess it is the question you said. It's about making sure you've thought through what you think the data is that you need to collect, and how you'd have it analysed. And I think that's also something we see a lot of. We're starting to see particularly the larger companies collect a lot of data, and they may have been collecting data over 10 years, but it's not necessarily useful if it's not accurate or it's unknown. And so there's some thinking to go into that. But Janet sounds like she's well on the path, so that's pretty exciting.
Thanks, Cori. And we're going to finish with you, Shaun. How does this scenario tie in with your economic predictions for the future?
Yeah, I mean, it sounds like Janet's doing pretty well, so go Janet. I think broadly it does fit quite well with our vision. I mean, I think the small difference is we probably wouldn't expect Janet maybe to own the data and be necessarily being able to sell it. And the other thing I suppose we think is that the data, you know, to the point just made, the data in itself may be not that valuable. It's really the analytics that Janet can put off the back of that, which is to say, this is what the data tells you about your sort of, you know, fleet of trucks or something like that, and when they need to be maintained, which is going to be the true value add.
Great. Well, thanks very much, Shaun, Cori, Jonathan. I'm going to hand back to Samantha Martin now, because it does look like we have quite a few questions in our Q&A, and we'll finish off with that. Thank you.
We do. We've had a lot of questions come through, and I'm guessing I'm going to throw them out to all of you, and you can see who's most relevant to kind of take it. David has asked, do you have any positive or negative safety lessons early adoption of robotics is taught?
Early safety lessons. So first of all, safety has got to be the number one sort of thing when you're going into this. So when I was giving this little tour, I talked about these collaborative robots that are theoretically safe. They're only theoretically safe if you don't use them. So as soon as you put anything on the end of these robots, imagine this very theoretically safe robot, but now has a chainsaw on the end. It's clearly not safe anymore. So so that needs to be designed into the whole solution. So our initial observations are that you have to do that, just like any other process, particularly in workshops. That has to be one of the constraints is safety. You just make it part of the solution. Don't forget about it. It can't be something you come back to at the end when you've finished your design.
Excellent. And Janine has asked, I guess, what impact does cybersecurity threat pose to automated vehicles, and how easy is it for drivers to reassess control in such circumstances? And I guess that goes beyond vehicles. It goes to all systems. I mean, you know, what's the threat?
I think it's a serious threat. It's we've just been talking about it here in our last few weeks with our engineers about air gapping robots, which is, you know, so they're not connected to the internet. It's a very serious threat. So, and in fact, so as well as trains, we also have birds in our shed. Our shed is so large, it has its own micro environment with different species. So cybersecurity actually needs to be treated like safety. So you have to you have to build that in. Very few people do actually treat it like safety at the moment, but it needs to be treated like safety because it's definitely a problem. It's a big deal.
Shaun, I've got one for you. What is the proportion of additive manufacturing / 3D printing in the projected 52 billion GVA that you were kind of talking about? Do you happen to know?
Not off the top of my head, but it was pretty small, to be perfectly honest. We didn't. Although obviously it's been being adopted in a few places, we didn't see evidence at the time we were looking at it of a significant increase. But obviously, I think the jury's still out on additive manufacturing, and there is the potential for it to really take off. But we didn't see that at the time, or with some of the interviewees that we were speaking to.
Do you anticipate, obviously, a lot of your research was done pre-COVID. Do you anticipate that the timelines have completely shifted in a post-COVID world, that some of the benchmarks that you were kind of looking at have just come forward exponentially?
Yeah, really good question. And I'd love to hear what other people, closer to the ground say about this, because we're potentially updating this report. We've had people have told us that, there's been a massive acceleration of adoption over the last 6 months, which would make sense. And we'd be really interested to see what that, whether it's across all of the technologies or there are specific technologies where it's accelerated even faster. We are sort of excited about that potential, because that's obviously happened. COVID has accelerated the offline to online transition generally, and just to see how that's actually affecting the mining industry would be really fascinating. Cori, Jonathan, Sue, I'd be to some extent more interested in your opinions on that.
I think, honestly, in the mining space, we're dealing probably day to day more with METS companies that are, deploying new technologies into the mining sector, and I think they, as businesses, have been impacted by COVID in a negative way. However, they are still pushing through with the innovation projects, and we've been looking for perhaps more diverse investments to keep those innovations coming into the market. I think there has been general conversation about a slowdown of some of the innovation uptake in the wider mining sector, and I think there's a great push on a consciousness and a push on now to make sure that the METS companies are getting the kind of public and private investments they need to get through this period and continue to not go into mining but diversify their own markets as businesses as well. So probably not the answer that we're hoping for, but I think it would be remiss of me not to say that I think companies have felt the impact of COVID and the ability to work and secure the innovation investment required.
I think, look, we're going to run out of time for all of these questions. I guess what's one bit of advice that you would give to businesses or industries who are considering transitioning their workforces through the induction of technology into the workplace?
The quick answer there is they need to get a small win within their company adopting something so that everybody in the company can see it. So our example working with UAP is, once the first robot was in and helped, an employee do stuff, then the next employee turned up and said, I want a robot too. And then the next one said, well, I actually want one as well to do this, and it was by leading by example, choosing something that was a high chance of success and then demonstrating that it's actually a productive thing to do.
I think there needs to be a much more proactive approach towards workforce planning, because I think in a number of areas you can probably see where the technology is going to have an impact and which occupations are going to be impacted. And I think it's, for every company, we really should be considering what does that mean in terms of the skills that are going to be required in the future, and how can you help existing employees to get those skills?
And yeah, I agree with you, Sue, because we do know to a certain extent, and I think sometimes it's not just filling the workforce with a fear of it. It's having the actions to put in place that allow them to see that what their future is and the steps. And sometimes that is formal training, and that's probably not where we're deeply involved. We are doing. We have training skill sets and processes embedded into our projects that are upskilling the staff as we go, and that's how we do our work. But there's many other ways to skill staff. So I'm saying it's. I think I find that staff are really anxious. They sort of know, because there's all of these, research everywhere in the world says that how much am I impacted? Like, this is my job here. I'm like, look, there's 70% chance I'm not going to have a job in 2 years. There needs to be an action. I think that's what Sue's indicating. Like, let's be really proactive about putting those actions in place. The other thing I would say for the Janets and others of the world who have businesses, they're not on their own in this process, and there's so much information support and opportunities to collaborate, to resolve, move forward, tackle these adoption and workforce opportunities. So don't do it alone. Reach out. That's one reason why the Hub is here. That's one reason why other great companies are here and research institutes is to be able to assist with that.
Yeah, and I just very quickly add, just transparency of decision making is also alongside workforce planning is really important. So as companies know more, they can just be very transparent about their approach, their process, their implications, the decision making framework, and that can all be helpful for the company and the employees.
Excellent. Well, I think we've run out of time. So where can people find out more information? I'll kind of go around to each of you if they want to find out more about the work that you're doing and how they can get involved. So how do people find out more information?
Well, for the Hub, we have a presence on socials, on websites. You can just call us, and you can even come and have a tour and talk to us. We're up and we're real life. We're on the ground. Because we're manufacturing, we never actually stopped. Of course, you can just schedule a call as well. So we're very outwardly focused that way. So we're really easy to get in touch with.
Yeah, and the same for us. I mean, we obviously have a website, LinkedIn, phone call, any or all of the above.
Well, and I better quickly, give a plug for the Queensland AI Hub, which I haven't really mentioned, but we have similar presence if you want to get in touch. But I also have another role as the chair of Robotics Australia Group, and we're in the process of writing the mining METS section of the next version of the roadmap, and having a look at what some of the influence of COVID is having on the sector and what that means for robotics is part of that. So look out for the next version of the roadmap.
Well, thank you all so much for your time. It's been really insightful, and look, I can't wait to see the reports coming out in the next kind of 6 months to see where we're placed and what opportunities have come from this unique situation we'll find ourselves in. But thank you all very much. The recording of this will be released next week, so anybody who didn't get a chance to see all of it or they want to watch it again, we'll release this on our websites next week. But thank you all for your time, and hope to see you in person all sometime soon.
Thanks, everyone.
Thank you.
Thank you.
Bye.
Bye.